Good morning. I am here to talk about the multi-threaded server that appeared in OpenEdge 12. And so what I've done is run some benchmarks to compare performance of multi-threaded servers as opposed to multiple unthreaded servers like we had before, where in both cases each server process is serving multiple clients. So we have in our test setup, there's two machines. This machine happens to be the same one that we used for the secret bunker. This is the server. It's a fairly fast machine, and we've used it a couple years. Then we have a machine for the clients to run on. This is a Lenovo ThinkCentre M82, which is a desktop PC. It has an Intel Core i5 CPU, 4 cores, 32 gigabytes of memory, and one M.2 SSD. So the Fergal test time on the server machine is about 0.4 seconds, which is really good. The Fergal test time on this machine is 2 seconds, which is barely acceptable. But because this is the client machine, it doesn't matter, because we're not writing to disk. Also, the bandwidth between the client and the server is 801 megabits per second. It's a gigabit Ethernet connection that goes through a switch that's between the two machines. So they're close together. And so the network connection between them can run pretty close to full speed. Okay, so that's the test setup. Now, here's all the database parameters related to networking, which are on the server. And this black line, 2/3 of the way down, all the stuff below that line we have tinkered with in this test. All the stuff above the line, we don't touch that. It stays the same for all the test results I'm going to show you, with one slight exception, which is, I'll get to that. So the benchmark that we're running is the ATM benchmark we've been using for years and years. It executes a small update transaction with 150 users. So the client machine has 150 sessions running on it. And it's just barely able to handle that. It gets overloaded. So then we have a bunch of database parameters that we always set for the baseline configuration for the server. So we kept these constant for all the tests here. We're not trying to tune the database. We're trying to measure network performance. So we're only tinkering with network-related parameters. OpenEdge 12 has changed the default values for various things. So here's some of them, mostly the ones related to things we're doing. So the threaded server is on by default. You get maximum of 5 servers with 125 clients per server. And minimum clients per server is 1. And the message size is 8192. Then the prefetch priority, as I learned yesterday from Tom Bascom, you should set that higher than 100. Yes?
It's prefetch numRex, not prefetch priority.
Oh, sorry. You're right. I meant to put numRex. All right, I'll fix that.
Don't look behind the curtain right now.
That's right.
Nothing to see.
Nothing to see.
Okay. So the prefetch numRex is how many records to store in a network message. But because the message size has been increased, and I've increased it more than the default, it's not going to fill up any of the messages to their maximum size. However, for the tests that we've run here, it doesn't matter, because we're doing these small update transactions, so we're not sending large messages anyway. I have some query tests that I was planning to run, which would have done large messages, but I can't run them on the client machine because it's too small. So I have to figure out what to do about that. The client machine runs out of CPU, and then they can't start all the clients. Okay, so the max message size should really be 16384 or some other bigger number than 8K. At least that's my opinion. And the prefetch numRex should be higher. Tom says set it to 1,000. A big number is good because you want to fill up the message buffers as much as possible. And it's not going to hurt you if you're going to only send one record. The prefetch prefetch numRex is irrelevant. So set it to a big number. Okay, so baseline test that we did was on the server, run with self-serving clients and see how fast that goes. So here's the results. All of these tests, they run multiple times. So if we get weird results for some reason, we can see that. And if the results are not consistent. So in this case, we get 1,761 transactions per second. So that's the fastest we can go. And for this test, all of those network parameters don't matter because we're doing self-serving clients. The next test, we ran with the defaults that I listed earlier, except that I raised MN to 200. And you can see that it's quite a bit slower. So here we're running MI1 and MA125, so we can have 125 clients per server, and the threading is enabled. Then, again, threading enabled, but this time, bigger message buffer size, and MI1, MA1. So what we're doing here is comparing multiple server processes, we're going to get 150 servers, one client per server, both cases for the threaded case and the unthreaded case, one client per server. So we get 848 for the threaded server enabled. And then if we turn the threading off, we get 1,200 and some. So that unthreaded servers are faster in this case. I don't really see why that should be. They should be the same. Because you got one thread serving one client, or you got one process serving one client, so that you should get the same result. So there's something wonky there. 12.8. Yeah, it's 12.8 alpha. Then what happens when we raise the -MA value? So threaded servers enabled, and we set MI and MA to 5. Now, in all the subsequent tests too, MI and MA are the same. And I did that so that it would fill up servers before starting a new one, rather than going across all the servers and balancing across them. And the reason I did that is because I wanted to have as few servers as was feasible. So fill up a server first before you start a new one. That was the goal for doing that. Okay, so we get just under 1,200 in this case. So it's faster than the previous result where it was one and one. Okay, and then with threading off, we get slightly more, but not a dramatic increase. So here it's 5 clients per server or 5 threads per server. Next, we raise -MA some more. So with the threaded server enabled, we get 1,160 or so transactions per second. And at this point, we're probably close to maxing out the client machine or the network. Network gets overloaded too. I have some graphs after these numbers, so then you can see how they relate to each other. Okay, turn the threading off. Notice that it's faster. So we go from 1160 to 1450 about. If we keep increasing -MA, we get better performance. So did I just put these in the wrong order? Yeah, there we go. Okay, threaded server enabled for -MA 20. We get 1,200 and some. So it's slightly better, but not much, than the MA 10. And then, crap, I got these slides out of order, sorry. If you turn the threaded server off, then it's faster again. So we go from 1,200 and some to 1,500 and some. So in all of these cases so far, the threaded server has been a bit slower than the unthreaded server, even in the case where they should be the same. And I have no explanation for that. Okay, then we go MA50, and we get a similar result to the previous one, 1200 and a little bit. And then for the unthreaded server, we get almost 1600, a little over 1600 at MA50. So again, the unthreaded server is a little bit faster. Increase MA to 75. So at this point, with 150 clients, we can do it with 2 servers. But one of the things that happens with the servers is when they have too many clients, they end up competing with each other for resources and run out of gas eventually. I don't know exactly where that point is, but with MA over 100, it still works pretty good. Okay, so again, 1200 and a bit with the threaded server enabled. So the last 3 tests have been all the same for the threaded server. And then we get 1200 and a little bit for the unthreaded servers. So now the unthreaded servers are about the same as the threaded ones. Okay, so here's a chart that shows all those results. The top 2 lines, one is the self-serving client test that we started with, and then the next row is the one with the default network settings. And you can see that the default network settings aren't good, because as soon as you start changing them, you get better results. Okay, so if you put those in a graph, here's what you get. So with dash MA1, you get a 800 and some, and then it goes up to 1200, and then it just stays there. So it's flattened out. This is with the threaded server with threads enabled. And then here, what do you get with threads disabled? So again, it ramps up, but it flattens out here too. It just flattens out at a higher value. So instead of 1200, we're flattening out at about 1600-ish. The last 3 are pretty even. Yes? Oh, you're right. That last number should be 1200. That's a mistake on my part. You're right. Huh? I know. I'm not going to fix that now. Sorry about that. Anyway, so it's clear that the client machine or the network has run out of gas because we can't go any faster. But a bigger machine would be better. We're running 150 clients on a desktop PC because that was all I had. Yeah, Mike.
So I want to comment that I did the same test for a customer
Yeah.
that was trying to increase MA. So we looked at their workload and we mimicked their workload. So it wasn't a scam. It was actually a workload that mimicked what their typical workload was.
Yeah.
And we saw the same results that you could scale MA up to 50. This was before the credit, so this was just the regular server.
Yeah.
That was the time slice server, we call it. And we saw that we could get MA of 50 without any problem.
To 50? Yeah. Well, so did we here, but
I'm just validating this, that this is just, while this is in a laboratory, we did this for a customer.
yeah. Okay. Well, that's good. Thanks. Any questions about any of this?
I'm curious to know what your CPU and memory loading was like on the server.
Oh, it was pretty low.
Okay, so you weren't really noticing any difference between single and multi-threaded.
On the server, no. The server, it's got 12 terabytes of disk, which is striped. And so the disks are fast. It's got 64 gigabytes of memory, so the whole database fits in memory, actually. So the server is just loafing along for the most part. I was looking at what was going on in the server with Promon and with Top. So, but the client machine, when you look at the CPU there, it was pretty high, and I don't have a good tool to look at the network. So I'm only guessing that the network was maxed out, but I'm not sure about that. I suppose I could calculate how much data was flowing across the network based on the messages that were being sent, but I don't have a tool to measure it anyway. Okay, so what do we learn from this? So one of the shortcomings of what I've done here is this is just one test case, and it's not particularly realistic. I have some query tests as well, but I can't run them because they fail because the client machine runs out of gas and the test harness can't start them all. And I didn't want to go lower the number of clients because then we couldn't compare with any of these other results. So more exploration is needed. Okay, so but what we can see is that both the threaded and multi-server throughput flattens, and I expect if I keep raising -MA, in the threaded case, it'll taper off too. But I haven't done that because I stopped at 75. So the self-serving clients are still faster than the network clients, although I have observed test results in the past where they were close to equal. But that was some years ago with slower hardware. Anyway, that's what I've learned so far from these tests with the multi-threaded server. One of the things that should be true is if you're doing queries and you're sending these big messages, the threaded server ought to do that better with multiple clients than the multiple client server that switches between clients, because you can get more concurrency with the threaded server, in theory. So, that's all I've got. Questions? Brian?
I know and understand the ATM is obviously update heavy, and given Mike's thoughts of Mike's comments on architecting a benchmark based around closer to what the application is. My application's 95+% read heavy.
Most applications are.
What would you surmise be different with this from the threaded versus non-threaded in that configuration? Do you think it might be any different or not?
I would expect the threaded server to work faster than the non-threaded server.
But you expected that here as well.
I did.
Yes.
My expectation wasn't met. Yeah, over there.
There are server-side joins involved in this test.
In this test, there was no server-side join. The transaction is find an update, find an update, find an update, create, commit. Okay, any other questions? Yeah.
In the threaded portion of your test, so you've got 150 clients. How many server processes did you get to? Was it all on one server?
Well, depends on what MA was set to. So if you set MA to 10, you're going to get 15.
Okay, but why would you want such a low MA on a multi-threaded server?
But because I was trying to make the comparisons more equal so that the workload would be the same for both cases for the server.
Are you suggesting he should have been MI1, MA50, and compare that to?
I'm just curious, like, what if you had one server and all the clients are on that multi-threaded server?
Which
It's still one thread per connection.
That was the first one.
didn't you do that? That was the first one, wasn't it?
The first one was one client per server.
One client per server?
Yeah, 150 servers.
On a multi-threaded server?
Yes.
Yes, multi-threaded and not
Just to compare them, right?
Okay, so let me go back to that.
A lot of server processes.
It doesn't make sense. But
Yeah, but
Okay, so here's the MA1 case. So threaded server, but since MA is one, you get one thread per server because you get one client per server, and you get 150 servers.
So you have lots of processes.
Right. And in this case, same thing, but with the threading turned off, you get one client per server, 150 servers.
right. So the number of processes are the same here,
Right.
but
Right.
it's dramatically different.
Right. So each server process, whether it's threaded or not, is serving a single client. So they should be able to give you the same result.
Okay, granted, but if I were trying to optimize a multi-threaded server, I wouldn't be setting MA1. I'd be setting like MA150.
Yeah. Okay. So in the last test case, I had MA75. So we ended up with two server processes with 75 threads in each one.
What's your MN?
My MN, 200. And MI is the same as MA.
But MI is going to force you to spawn a bunch of servers.
No, MI is going to force you to go another server once you got to 75.
It's
You
fill
fill
and
up,
spill.
you fill up 75, you hit it, get the next server, fill up 75.
Right. That's the whole point of making them the same, was to get that effect.
Oh, okay.
MI1 would have you go horizontal. MI5 says
Okay,
go 5, then
MIS
go
is
horizontal.
MA.
Yeah. So if you had 150 clients and MA5, let's say, and MI1, you'd get a shitload of servers with a few clients in each one. And I was trying to make the servers do as much work as possible per server.
So the comparable would be, to get to your point, the comparable would be the MI50 or MI75, right? 50 would be 3 servers with
Right.
50 threads each versus 3 servers serving 50 clients, time slicing.
Yeah.
Right.
So it is a comparable test because the number of processes are the same. One's using threads inside the process. One is just homegrown time slicing.
Yeah. That was the whole point of getting both cases to have the same number of clients, was so we could see how they perform relative to each other, which is a different goal than getting the highest performance you can get by whatever configuration you could dream up that would work better. So spreading out a smaller number of clients across more server processes might work better for the threaded case. I don't know. There's an infinite number of things we can test. But yes.
So, despite the fact that you have to look at other transactional, or bigger transactions, why should someone use a threaded server in this case? So it doesn't make any sense to use a threaded server.
Thread is supposed to be lighter than a processor.
But remember, this is one workload and it's a synthetic benchmark, so your application may not yield these results.
Yeah.
Right. So
That's right.
this was in the lab, and so the testing I did for a customer was replace their workload, get a workload that matched their record reads, record create, update, delete, which we did, and then we went from MA2, 3, 4, we went all the way up, and we went up to 50, and this was on the time slice server, not the threaded one, because the threaded one didn't exist when we did this. So it'd be interesting to do that on the threaded one as well.
Yeah.
But the results I got mimicked what was done in the lab. So I don't know how the threaded would behave, but certainly the time slice one behaved exactly what Gus was showing here.
Yeah, but the answer to your question, why should you use the threaded server? Well, yesterday the answer to that was because Progress told you to, because they set it on by default, and there was no data to go by. Yeah.
Isn't it the case that it won't have server-side joins with the non-threaded server?
Correct.
I thought that server-side joins were only supported with the threaded server.
That's correct.
Yeah. But this benchmark doesn't use joins at all.
For using the multi-threaded server, that's one way.
Yes, that's an argument.
Well, yeah, so the results I've got are not conclusive because we haven't tested enough scenarios. And server-side join is something that we should test, as well as various kinds of queries.
If you wanted to test your application, the threaded server is a login broker parameter, not a primary broker parameter. So you could have 2 4GL brokers, one threaded, one not, and connect clients to different ones and see how they perform side by side.
Yeah.
Yeah. Right, and so this is all the data I've got, and it's not enough. Any other questions? Okay, thank you.